For lesson 1.2, we are going to be getting further into the distributive property, and you're going to see why pretty quickly. So I want to go through a few problems. Again, not going to do all of them, but it will give you an opportunity to see how some of this work is being done. And if you have questions after that, please feel free to reach out. So for number 1, since we're distributing, we're taking what's on the outside of the parentheses and distributing it to whatever is inside that parentheses. So 2x times 5x will give me 10x squared. I'm taking x times x to give me x squared. 2x times 3 gives me 6x. Now the second piece of this, I'm going to take the plus 7 and distribute it in as well. So plus 7 times 5x gives me plus 35x, and plus 7 times 3 gives me plus 21. At this point, I'm now looking to combine like terms, and I'll see here that I have a 6x and 35x, both positive, that I can combine. I cannot combine the x squared with these x's. It is a different term. So when doing so, I end up with 10x squared plus 6 plus 35 is 41 plus 21, and this is what we're looking to do here. A couple more. For number 6, 5x distributes in to give me 10x squared, and 5x times positive 6 gives me positive 30x. For my second set, we'll take that plus 2 times 2 is plus 4x, and plus 2 times 6 is plus 12. Again, we can combine those terms because they have the same variable with the same degree. I would end up with 10x squared plus, and then 30 plus 4 is 34x plus 12. As a reminder, we cannot add these two terms together because they have a different degree. Same base, different degree. The last one that I'll do is number 5. Just bouncing around a little bit. Again, don't want to do all of them because I want you to own some of them as well. But to help out a little, take that 3x, distribute it in. 24x squared plus 9x. And now the reason I'm doing this one is because we have this minus 4. That's why I've been saying this plus 2 or positive 2 or positive 7, whatever it might be, because now we've got a negative in here. I'm going to take that minus 4 and multiply it in. So I'm going to distribute that negative 4 into the parentheses. Negative 4 times positive 8 gives me negative 32x. Negative 4 times positive 3 gives me negative 12. And now it is time to combine those like terms. So again, it's not always going to work out this way, but it just so happens to be the pattern right now to where those middle terms have a similar base and degree, or same base and degree. So 24x squared still stays by itself, plus 9 minus 32, so a positive 9 minus 32 ends up giving me a negative 23x minus 12. Put a box around it, and you are done. If you're thinking, wow, that looks like something we did earlier, we actually did this on a blue sheet to start the module. For number 13, it's a little bit more of a challenge. X plus 3 and x minus 2 are the two dimensions that we have. We need to find the perimeter. So remember, the perimeter is going to be walking all the way around the edge of the shape. So to find the perimeter, we're going to walk x plus 3 meters, then x minus 2 meters, and then x plus 3 meters, and then x minus 2 meters. So we're going to take all 4 of those dimensions and just add them together. So if we take x plus 3 plus x minus 2 plus x plus 3 plus x minus 2. So here's the first step, the second step, the third step, and the fourth step. What you'll notice is that there is a pattern that has formed, and I can make this a little bit easier for myself and say that there are 2 of the x plus 3 steps and 2 of the x minus 2 steps. When I do that, I end up with 2x plus 6 because I've taken and distributed that 2 in. And I also have 2x minus 4 because I've taken this plus 2 and distributed it in. Now I'm at the point where I'm combining like terms, and to combine like terms here, I'm going to take the 2x and the 2x to give me 4x. And I'm going to take the plus 6 minus 4. So 6 minus 4 gives me a positive 2. So my overall answer would be 4x plus 2 meters, or m. To find the area, a little bit more of a challenge. To find the area, we're going to be taking length times width. Well, the length is x plus 3 meters, and the width is x minus 2 meters. So this one here, again, for these, we're just looking for you to try. Can you try to get them figured out? And for this one, so let me give myself a little bit more room to work. I want to distribute, so I'm going to distribute the x to the x and the x to the minus 2. If I multiply x times x, I get x squared. If I distribute the x to the minus 2, I get minus 2x. The next part of this would be to distribute the 3 to both of the other terms. So plus 3 times x gives me plus 3x. Plus 3 times negative 2 gives me a negative 6. And just like we did in the first few problems, identify those like terms, and you should have x squared minus 6, or sorry, not minus 6, plus 1x, I got ahead of myself there, minus 6. So for the area, we are looking at x squared plus x minus 6, and we put these into parentheses because we're going to say that this is square meters, or meters squared. Since we're talking about area, we need to have our units be square units. For numbers 16 through 24, the big thing to keep in mind here is the greatest common factor. What is the largest thing that I can divide out of all of the terms within that particular problem? So again, not doing all of them, but just picking out a couple here. If I look at number 17, the first thing that I'm going to try to identify is something that I can divide out of both of the coefficients. So you could say, well, I can divide out a 2. You're right, but is that the largest thing that I can divide out of both of those terms? Well, I know that I can also divide a 4. So if I divide a 4 out of both of them, I would end up getting a 3 and an 8. Okay, good. So they both divide evenly. So I know that I can pull a 4 out of both of them. Then I'm looking at my x and my y values. To start with our x's, what we need to think of this as is, this is actually written out as x times x times x times x times x. And this one is written out 6 times. So what we're trying to do is we're trying to pull out the largest number of those x's as I can that are in both. So if I say that it's 4x, I actually have more pairs than just that one. I mean, if you see here, I've got 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. So I should actually be able to pull out 5 of those x's, and we represent that by saying x to the 5th power. Next, we'll identify all of our y values. So we'll say here and here, and they both end up having a variable of, or an exponent of 1. So we would say that the GCF for this problem would be 4x to the 5th y. For number 20, 6x squared, 18x, and negative 12. We need to, again, think about the greatest number that I can pull out of all 3 of these terms. What do they all have in common? If you were to say a 2, you're right, but that's not the greatest thing that they have in common. If you look at it a little bit further, you should see that I can divide each of these by 6. So we can say that, so far, 6 is the thing I can pull out. Now you might look at this and say, okay, well these two have an x. You're right. However, all 3 terms have to have the thing that we are pulling out, the variable, the coefficient, whatever it might be. And since this one does not have an x, the only thing that we can pull out is going to be the 6. Therefore, the GCF for those terms is 6. Hopefully this helps. Reach out if you have any questions.